Hello class, my name is Garner and my partner Logan and I have chosen an article that is a real concern today. We chose to do research on the article, Underwater Earthquake Sound Waves Reveal Changes in Ocean Warming, from ScienceNews.org, written by Carolyn Groundling, published on September 17, 2020. Let's have a look into our oceans. There are many events occurring in the ocean today, but climate change and global warming seem to be the biggest concern to scientists. The temperature of the ocean has changed over the last few years, and there are many methods of finding that. The ocean has sound waves that come from the vibration of water molecules, which can help us find the temperature of water. As we learned in class, water molecules move faster at a higher temperature. It causes larger sound waves in the ocean.
One of the methods of measuring climate change through ocean temperatures is through Argo floats. So Argo floats are a device that get dropped from a ship or an aircraft to the ocean. So they get dropped in the ocean and then they go down to the ocean about 2,000 meters, like they drop, and then they drift along the ocean floor for a couple of days, approximately 9 days, and then they're pumped with oil and they get shot back up to the surface. And as they're coming back up to the surface, they're calculating temperature changes and salinity changes. And then once they reach the surface, the data that they collect are transmitted to forecasting centers and climate centers. And then it gets pumped back with oil and shoots back down to the floor of the ocean, like not the floor, but 2,000 meters. And it gets shot back down and then it drifts again. And then the cycle continues and it goes up and it goes down, measuring those temperature changes and the salinity changes. So over here in this graphic, you can see kind of the process of the Argo float and its journey from getting dropped by the aircraft to like transmitting the data. While Argo floats are pretty accurate while measuring temperature changes and things, they have a little bit of trouble like deciphering the data when they have been undersea ice, because it's obviously going to be a lot colder under the ice. And in deeper areas, like they can't really measure that far the distance, so they only go up to about 2,000 meters. Another method of calculating climate change through ocean temperature is through the use of the SOFAR channel. SOFAR stands for sound fixing and ranging. It's a horizontal layer within the ocean that has a different salinity and temperature, and it just kind of creates like its own layer. In 1979, Walter Munk and Carl Wunsch developed the idea of ocean acoustic tomography. So this process used the SOFAR channel in order to like have a measurement of distance. And so they wanted to shoot sound waves into the ocean, just like down into the ocean, and then use when they hit the SOFAR channel as like a way to know where it was. And so when the vibration from the sound waves is moving through the water, like the molecules of the water vibrate at a certain speed. And when the water heats up, the vibration of the molecules like gets looser because there's more heat, so the molecules have more space to spread out, and so the molecules vibrate faster. And so you can see the difference in the vibration when it's in different temperatures. And so they wanted to shoot down sound waves to this channel that was a different temperature in order to see, one, the difference in temperature, and also to use it as like a distance thing, because they knew how far down it was and they knew that sound waves could penetrate pretty deep into the ocean. But before they could start their experiment, environmental groups lobbied to shut it down because they thought that the sound waves were going to be too much for the ocean, and that like the ocean animals weren't going to be able to handle it because they were not a natural occurring thing that happened within the ocean. But as we've come to learn, the ocean is a very loud place and there's a lot of things going on. And so the use of sound waves wouldn't necessarily be as damaging as these environmental groups thought that it would be in 1979. So this project of ocean acoustic tomography was shot down before it even began, um, kind of for no reason, because with new evidence, we find that the process of this wouldn't be as harmful as previously thought.
Seismologist Wimba Wu and his colleagues resurfaced the decades-old idea of using the speed of sound in salt water to estimate the ocean's temperature. They tested this idea by using earthquake-generated sound waves that traveled across the East Indian Ocean to find the temperature changes from the years 2005 to 2016. These sound waves can travel thousands and thousands of kilometers. Wu and his colleagues devised a workaround that sidesteps any environmental concerns. When an undersea earthquake rumbles, it releases energy as seismic waves known as P and S waves that vibrate on the abyssal plain, as shown on the slide. The temperature of the ocean waves has a major effect on the size of the waves, and they're starting to grow larger and larger. This is important because it can affect future generations because they will be dealing with deadlier waves and possibly tsunamis. If they continue to grow, and there will be higher chances of a natural disaster occurring.
Through these different methods of going into the ocean and finding temperature differences, we have been able to find that there has been a 0.044 degrees Celsius increase in overall climate over the past decade. This may not seem like a big percentage when looking at it, but that doesn't mean that you shouldn't be concerned. Global warming affects everyone and everything around us, whether it be our atmosphere or our plants or our animals or yourself. And so it's important for us and future generations to take into account what's happening to our earth and how to fix it.
Thank you.
Thank you.